My name is Bryan, and if you're working in controls, you know this feeling. You've hit a wall. Your Micro800 application is totally maxed out. You're out of I/O, and you've got to expand. Now, that next decision you make is absolutely critical, because the expansion module you pick can either be a total game changer for your project, or turn into a complete headache. You know the drill. You've got to add more temperature sensors, monitor new process signals, drive a few more outputs. The expansion bus is your only option. But how do you decide to use that bus is going to directly affect your panel size, your project budget, and yeah, even how complicated the code is that runs the whole machine. And believe me, the stakes here are super high. Make the wrong choice and suddenly you're buying extra hardware, gobbling up precious DIN rail space, and worst of all, you're stuck writing line after line of extra ladder logic just to make up for what that module couldn't do. But get it right and you can get a lean panel, a clean, efficient program, and you can even have room to grow later. So the big question is, how do you make that right choice? Well, it really starts with designing for efficiency right from the get-go. And honestly, that is the whole philosophy behind the Spectrum Controls 2085 line of expansion I/O. It was engineered specifically for the Micro800 platform with this in mind. Okay, so the first big idea here is I/O density. It sounds a little technical, but the concept is simple, and it's incredibly powerful. Just pack as much capability into a single slot as you possibly can. This isn't just about being neat. It directly lowers your project cost. Think about it. You're buying fewer modules, which means you need a smaller enclosure, and you're going to spend less time on wiring. It's all about getting more bang for your buck. So, just how dense are we talking here? Well, let's look at a number that really changes the game, especially for analog inputs. It's a number that can fundamentally change how you design your next system. And that number is 16. That's right, 16. This little powerhouse delivers 16 4 to 20 mA analog inputs in one single expansion slot. That is the highest analog density you can possibly get on the Micro800 platform, period. Just let that sink in for a second. For any job with a high point count, that is a massive reduction in panel space and hardware cost. But hey, this isn't just about cramming more inputs in. It's also about being intelligent. So let's talk about something called module level scaling. Instead of forcing your PLC to do all the heavy lifting, all that math is converted to a raw signal into something useful like PSI or degrees Celsius. The module just handles all of that internally. And by taking that tedious job away from the PLC, you get a huge win. Your ladder logic becomes way simpler and so much easier to troubleshoot. Plus, you actually lower the PLC scan time, which means your controller can react faster. When you're trying to manage 16 channels on a small controller, trust me, that performance boost is a really big deal. Okay, so we know these modules are efficient, but how do you pick the right tool for the specific job you have in front of you? Let's take a quick tour of the toolkit, so to speak, and see how you can match that module to your application. So here's a really common decision you might face. On one hand, you've got the IF16C, our high-density hero. Its job is to pull in the maximum number of channels. It's perfect for things like large processes, monitoring systems. But then on the other hand, you have the IR8SC, which is a dedicated 8-channel RTD module. Its focus isn't density. It's all about specialized accuracy. It's ideal for things like heat treat ovens where precise temperature control is absolutely non-negotiable. And when you see them side by side, the roles become super clear. Your choice is pretty straightforward. Are you just trying to bring in a high volume of standard process signals? The high density module is your answer. Do you need that uncompromising rock solid precision for temperature? Then you go with the dedicated RTD unit. It's your strategic choice you get to make, density versus dedication. Of course, collecting a ton of data is pretty useless if that data isn't accurate and trustworthy. So, what kind of features are engineered into these modules to make sure your measurements are actually reliable? This is where the engineering details really start to shine. First off, every analog module has 16-bit resolution, which gives you that really fine-grained precision. Next up, you've got 10 volts of channel-to-channel isolation. This is your shield against all that electrical noise and the ground loop problems that can totally corrupt your readings. And finally, you get built-in alarms and fault logging. So you have diagnostics right at the source, and you know exactly what's going on out in the field. Let me give you a perfect example: open circuit detection. Without it, if a wire on a temperature sensor breaks, it might just send some bizarre phantom reading back to the PLC, and you can make a really bad process decision. But with this feature, that same broken wire triggers a clear logged fault. Instantly, you go from chasing a ghost in your code to just fixing a physical problem you know exists. It's a world of difference. So, as we start to bring this all together, let's think about what this combination of density, intelligence, and reliability means for your next project. How can you take these ideas and use them to build a better, more efficient system right from the start? At the end of the day, it all comes down to 3 key things. You get a lean panel thanks to the high-density I/O. You get a clean program because of smart features like module-level scaling. And you get precision you can actually trust, built on a foundation of high resolution and signal isolation. That really is the whole package. Oh, and there's one more crucial point, and this is a big one. Every single one of these Spectrum Controls 2085 modules is fully licensed by Rockwell Automation and includes access to their Tech Connect phone support. You know that moment when you're on-site commissioning a system and the clock is ticking? Having that expert support in your back pocket is a massive, massive advantage. So, as you plan out your next build, just ask yourself this: is the I/O you're choosing making your design simpler, cleaner, and more efficient? Or is it secretly adding more hardware, more complexity, and more cost? The answer to that question will tell you if you've made the right choice, and it just might change the way you approach system design forever. Thank you for watching. If you enjoyed the video, make sure to leave a like and subscribe to Automation Nation. If you have any questions, drop them in the comments down below and one of our specialists will answer them. See you next time.